Okay, we'll work through the solution to quiz 4 in Mechanical Engineering Statics 1230. So we're given this problem description. We have a block D with a mass of 4 kilograms and block E with a mass of 6 kilograms. They're acting down here. We're told that X is 2 meters, so we can fill this in. This is 2. We don't know S. This is 2. This must be 6 minus 2. So this must be 4. This is also S on this side. And we need to find the force F and the sag S to have equilibrium. I'll give you a little points breakdown. I'm looking for a free body diagram for 2 points. The tensions TAB and TAC for 1 point each. Some equations of equilibrium. Some of the forces in X and Y have to equal 0. And then our solutions of the value for F and the value for S. So here's our free body diagram. So I'm going to take this at point A. So here's my ring. I have force acting that way. This is tension AC, and that's acting. This would be 2. This is S. Then I have another tension AB. That's going to be 4 and S. So I wanted to see some indication. You could use an angle. Oh, my 2 went away. Angle to designate that, but we needed to come back to the geometry for that to solve the values. So our tensions, since this is a frictionless pulley, both at B and C, our TAB equals the weight of, or the mass of D, which is 4 kilograms, times 9.81 meters per second squared. So that gets us a weight of 39.24 newtons, and that tension is the same on both sides of this pulley. So that's what's acting at A. And then tension AC is going to be 6 times 9.81 meters per second squared. So that gets us 58.86 newtons. There's a decimal. Alright, so got those first bits down. Now we need to do our equations of equilibrium. So the sum of the forces in X to equal 0. So what do we have? We have TAC acting in the plus X direction. And how much is that going to be? It's going to be 2. So it's going to be the cosine of this angle, which is going to be 2 over the square root of this squared plus this squared. So that's that hypotenuse. So we're going to have 2 squared plus S squared. And then acting in the negative negative X direction, we have minus. Oh, that's going to be times tension AC. And we're going to have minus tension AB times, it's going to be 4 over the square root of 4 squared plus S squared. So there's that equilibrium equation. So I could solve for TAC in terms of TAB or vice versa at this point. And then our equations of equilibrium in Y. So we're going to have 0. What do we have acting up here? So we're going to have tension AB times S over square root of 4 squared plus S squared plus our AC tension. So part of that's acting up. We're going to have S over square root 2 squared plus S squared. And then we're going to have minus F acting straight down. Alright, so now I can solve this in terms of that or vice versa and plug that in. I know my tensions, so I can solve these values. So I can solve this for S up here, or I can solve this for F and work backwards. So I'm going to operate through solving the F in terms of S here. So F, starting to fill some values in. So I'm pulling this to the other side, so you get 0. tension AB is 58.86 times, oh, I did fill in my S. Where did I get my S? Okay, sorry. Let me start over with that. So I'm going to take this and find my S. So let's see, I've got 58.86 times 2 over 4 plus S squared minus 39.24 times 4 square root of 16 plus S squared, and that equals 0, so I'm just going to slide that to the other side and make that equal. Multiply both sides here and basically square both sides. So I'm going to have 58.86 times 2 squared over 4 plus S squared, 39.24 times 4 squared over 16 plus S squared. Now if I cross multiply those, I'm getting some crazy big S numbers here, but I'll get 16 plus S squared times 58.86 times 2 squared is 4 plus S squared times 39.24 is 4 squared. So if I solve that out, I get S squared equals 11.21. So S is 3.349 meters. So 3.35 meters. Alright, now putting that back in over here, so I get 58.86 times 3.35 over 16, square root of 16 plus 11.21 plus 39.24 is 3.3449 over 4 plus 11.21. F is 75.73 newtons. To 3 significant places, 75.7 newtons. And that's acting in the downward direction. So like most problems, we start with a free body diagram, solve anything that we know acting on that. So in this case we knew the tensions. Then we formulate our equations of equilibrium, x and y. In this case we could solve our S or our F in terms of S and then come back. So I solved the S first. Maybe not the cleanest way to do it, but on the quiz maybe that's what you would have resorted to as well. So since these are equal to each other, I can square both sides. They're still equal to each other. I end up with some large terms here, and when we do the math on our calculator, we get S squared is 11.21, S is 3.35. Plugging that back into F, we get 75.7 newtons.